Assalamualaikum and good day to everyone. Now we are going to study moment of force in 3D. So in 3D we are using the vector formulation. So moment in 3D can be calculated using Scala 2D, but it can be difficult to finding D when the force in 3D and also time consuming. So it is easy to use the vector cross product. So here we have moment of force about point O is equal to R cross F. So this one we name it as cross. Alright. So let's see here. So this is the F. So our F is in 3D. So now what is the R? R is the vector. Is the position vectors from point O to the line of F here. So this is R. R is the position vector. So now R cross F. So what is the directions of moment? So now this F is go to this point O. So here we have the directions of moment is counterclockwise. Based on this figure, we can see that if we are using the formula 2D scala, moment is equal to FD. So now let's say this is the F. So this F in 3D. So we need to resolve into three components, which is Fx, Fy and Fz. So we need to determine what is the moment arm, what is the perpendicular distance. Let's say we want to get the moment of force from this point O. So we need to get what is the perpendicular distance to each of the forces here. So definitely we have the distance in X, in Y and in Z. So it will take time. So that is why it's more easy to have the position vector here, which is the position vector R. If you want to get the moment of force about the point O here, so we can use the vector product, cross product, which is R cross F. Here, to find the cross product of any two Cartesian vector A and B, we can use the determinant. So this is why moment can be expressed as a moment of force is equal to R cross F. So this is the determinant. So this determinant, you may write the Cartesian I, J, K here. And then R you can write into Rx, Ry and Rz. And also for the F also in Cartesian, Fx, Fy and Fz. Because you may see from this figure that when we have the F in 3D, so this F in 3D is resolved by the Fx, Fy and Fz. And also, if you want to get the position R, so this position R, so is determined from this point O to this point F. So we need to get what is the coordinate in I, J and K. So by expanding the above equation, so we can have 2 times 2 determinant. So how to solve that? So we can simplify here. Moment of force is equal to, you may write like this. So this is I, and then must remember, so we need to minus here, and then this is for the J, and we need to plus here, and this is for the K. So after this, you can see how to derive this moment. Now, what is a vector cross product? Here you can see that the cross product of the vectors A and B, we're going to get C. So here we can have that two vector A cross B. So this is A cross B. So we can get the C. So what is the angle in between A and B here? So here you can have that the magnitude of C A cross B is equal to AB sine theta. So theta is the angle in between A and B. So what is the UC? UC is the directions of the vector C. Here you can see that our right hand rule can represent the directions of the vector. How? You can see this is our term. So this term represents the vector A cross B. So this is our curl. So this curl is the vector A. So A cross B here. So this term represent the perpendicular axis from A cross B. So the A cross B, we can have the direction from our thumb here because the thumb show the perpendicular direction to the plane of A and B. Next, you can see here the law of operation. So number 1, commutative law is not valid, which means that if A cross B is not same with the B cross A, but if A cross B is equal to negative B cross A, so you may refer to this right hand rule. So now this is A and this is B. Now A cross B. So A cross B, we get C here. So but based on this figure, if we have B here and we have A here, so if B cross A, so we're going to have negative C. Next, if we have multiply by a scalar, scalar is similar as before, so we can direct apply this is scalar, multiply with the A cross B, so we can get as usual like this. Okay, and then next, as usual, if you have distributive law, so we can have the A cross B plus D, so we can have the A cross B plus A cross D. So proper order of the cross product must be maintained since they are not commutative. Here is how to determine the direction by using the right hand rule. So now this is our right hand rule. As usual, this is the term represent the Z axis and the curl represent the X and the wrist here represent the Y. So here we can have the I, J and K. So now we can say that if I cross J, so I cross J, we're going to get K. So this is counterclockwise. So how about is clockwise? So if clockwise, if we have J cross I, so this is J cross I, J cross I. So we're going to get negative K. Alright? So here, you can refer to the circle. So let's say, when we want to use the circle for the result, let's say we are using crossing counterclockwise, we're going to get the positive. And then opposite, if we are crossing the clockwise, we're going to have the negative. Now, we can use this circle. So based on this circle, so let's say this is the counterclockwise. So counterclockwise. So if you crossing I cross J, so you get positive K. So now you crossing K cross I, you get the J. Okay, now we try to crossing clockwise. So clockwise here, let's say we cross K cross J. So K cross J, we're going to get negative I. Alright? So this is how we can use the right hand rule. So vector cross into itself, we get the 0 here. I cross I is equal to 0, J cross J is equal to 0, and K cross K is equal to 0. So here, if the I cross j is equal to k, we're going to get the 1. Right, because we're going to use this into simplify the vector cross product. So here is what is the step to formulate the moment. So here, this is the moment. Moment is equal to A cross B. So you can write into this determinant and then how to solve the determinant. So let's say we want to get for the element I. So for the element I, we write I here and then in bracket, we can have that. So this is the element I, right? So this is the element I. We have cross. So now we left this AY cross BZ minus AZ cross BY. Okay, so that is why we write here. Okay, next we want to have the element J. So element J, must remember we need to minus. So student must always make mistake at this part, minus. So now we write the element J here. And then in bracket, this is element J. So in bracket, we're going to have that AX cross BZ minus AZ cross BX here. Okay. And then the last one, element K. So this is element K. And then in bracket, so this element K we cross. So here we have AX cross BY minus AY cross BX here. So this is, you can write. Now, let's solve the example 4.5. Determine the resultant moment by forces about point O. So, the first step, we need to know where is the force. So, the force is here. And then, where is the point of moment. So, this is a moment about this point. This is point O. Alright, and then the next step is we are using to apply this moment, which is we're going to have the R cross F. So moment about point O is equal to R cross F. So what is the R? So the R here is this. This is the R. So the R is this position vector. So R, O, A here. And then this is the F. So now, what should we do? The first step. So now we be given that this is the F1 and F2. So here, so we can have that F1 cross ROA plus F2 cross ROA. Or you can have that summations of force here. So in order to substitute this F, we need to summation. So F1 plus F2. So here our F is already in Cartesian. So we can directly solve the force resultant here. Okay. So now, how to get this position ROA? So we need to get what is the coordinate for A here. And then what is the coordinate for O? So let's say here O is 0I, 0J and 0K. So what is the A here? So A we have 4I, and then we have 5J, and then we have 3K. So the R OA is A minus O. So we can have that 4I plus 5J plus 3K. Then we can write the moment into determinant. So you can write the moment into determinant. So what is the Rx, Ry, Rz, and then what is the Fx, Fy, and Fz. Next, we have here the F is equal to F1. So we add in respective group, which is I, J and K here. And then we can have that the force resultant here is equal to negative 100I plus 130J plus 175K. So this is the ROA that we have established. Then we can have that cross product here. So this is the vector cross product, which is ROA cross F. And then here we can write into determinant. So now we can solve for the first element here. So element I. So we can write I here. And then this is the element. So this element is 5 times 175. And then minus 3 times 130. So this is, we need to write this one. Alright. Okay, next we need to have the element J. So for the element J, so don't forget minus. So this is the element J here. This is element J. So J. Okay, so now we want to write element J. So this is J. So J we have here. So J we have this one. 4 times 175 minus 3 times 100. So this is element J minus this one. J. And then the last one is plus element K. So this is the element K. So next is element K. So this element K, you're going to have that 4 times 130 minus 5 times negative 100. So this is the element K. So final answer, you will determine the vector for the moment about point O is equal to 485I minus 1000J plus 1020K. And then unit here we have a feet and pound here. Pound feet. Okay. Next example 4.6, we need to determine the moment F about point A. So as usual, we're going to use this cross product. Moment is equal to R cross F. So now what is the R? So the R, so this is the point F. So this point A, this point F. So we need to get about this point A. So we can get what is the position R here is the R, A, C. Okay. So now, look at the F here. So F here is given 80 Newton. So our F need to resolve into Cartesian, which is we need to get what is the Fx, Fy and Fz. So we need to resolve. So we need to resolve the F into Cartesian. So you need to get this component. So now, so this F we need to resolve. So now this is our, okay, this is our Z. Okay, Z. This is X and this is Y. Okay. So here this is X, Z and Y. So this our can say that this plane is the F prime, right? This plane, because we need to resolve this F to this F prime because we need to resolve into Y and X here. So now what is the F prime? So we need to resolve to F prime. So F prime is equal to 80 cos 30, right? So this is the F prime here. So now we need to resolve into component X here and component Y here. So what is the Fx? So Fx is, so we have here is 40, right? So we have that F prime. So here is the F prime. So Fx equal to F prime. So we write f prime 80 cos 30 f prime. But we resolve to the x-axis, so we use the sine 40. So here is sine 40. So this is the I. Okay, next fy. So how to resolve the f prime to component y? So here we have the f prime cos 40. So what is the f prime? F prime is 80 cos 30 and then cos 40. Right, so this one is for J. Right, and then and then we need to have Z. Okay, now this F resolve into Z. So Z is, okay, now downwards. So Z is equal to negative. Okay, negative. So we are using this 30 degree, right? So this 30 degree, Fz is equal to 80 sine 30. Right, so you can have the magnitude here, then you can get what is the F in Cartesian here. I, J and K. Right. Right, next, can you get what is the position vector of RAC? So, in order to get what is the position vector RAC, we need to get what is the coordinate A and what is the coordinate C. Okay, so now the unit for moment is Newton meter. So look at here. So here the distance is given in mm. So we need to convert to meter because the force is already in Newton, right? Okay. Now, what is the point C here? Because the point A here is as usual is 0, 0, 0. And then the point C here, look at what is the X, what is the I. So we need to get I. So this is the I. So R is 300 plus 250. So it's become 550. So 550 mm. So it's become 0.55 meter. Right. Okay. And then what is the Y? So Y is here. From this to this. So this is Y. So Y is 400. Right. So what is the 400? So 400 is 0.4. So 0.4 J. This is J. Okay, now Z. So Z is downward here. So Z is here, negative. So negative 200 mm is become 0.2 meter. So negative. So you get here RAC is equal to C minus O. So it's become 0.55 I plus 0.4 J minus 0.2 K. Then you can write into determinant. So to determine the M. Can you do that? Next, then you can solve what is the F in Cartesian here. So you will get that F is equal to 44.53 I plus 53.07 J minus 40 K Newton. And then this is the RAC. And then we can write into this determinant. And then write I, J, K. And then write this is the R. And this is the F. I, J, K. Then you can solve. Right? You can solve. Then so here first the element I. So you can write the element I. So it's equal to, so element I, and then minus element J plus element Z here. So you can have that for this element I. So you have this one, 0.4 times negative 40 minus negative 0.2 times 53.7. And then we move to J. So this is J. So this is J. J, you're going to have this one, 0.55 and negative 40, and minus negative 0.2 with this one. And then the last one, element K. So element K, you're going to have 0.55 times 53.70, and then minus with 0.4, 0.4 multiply 44.53. Right. So the final answer, you will get this one. This is the final answer. So the final answer is negative 5.39i plus 30.1j plus 11.4k. So this is the vectors, not yet magnitude. Newton meter. Next, we're going to solve example 4.7. So here we have the pole is subjected to 60 Newton force that is directed from C to B. Determine the magnitude of the moment created by the force about the point A. So now this is the force. So this force is directed from C to B. Okay, so this is the point A. So we need to get the moment. So now we can have two methods here. Okay, so first, MA can be defined from R cross F. So this one. So we can have that, this RAB. RAB, and then number 2, also you can have that MA is equal to R cross F. So what is the another R? You can have that. What is the line of action from point A to point F? Okay, because of this point F is directed from this UCB. You can have from, because of the direction is from C to B. So you can have this line. So you can have that this position vector RAC here. Okay. So can you write into determinant to get the moment of force about point A? Okay, don't forget here. So this is our force. Is it our force is already in Cartesian or not? So what is the step? How to express the force into Cartesian? Okay, now how to resolve the force into Cartesian? So here we can express the force into Cartesian. So let's say it is a FCB. So we need to multiply with the UCB. So how to get the unit vector CB? So this is the force. And then this is the UCB. So this is the direction. So we need to get the unit vector CB. So how to determine the unit vector CB? So we need to get what is the RCB. So what is the coordinate here? Coordinate B and coordinate C. So C here, what is the I, J, K? So C, I, J, K. So C here, I is 3 meter. So and then J, what is J? So J is 4 meter. And then what is the K? So we don't have K here because so K is 0. So how about B? So what is this coordinate B? So B here, P here is 1. Okay, so here is 1I. So 1I. And then how about J? So J here is 3 meters. So this is J. And then K. So K here we have 2Z. Okay. K we have 2 meter here. So this is coordinate for the C and B. So now how to determine the unit vector. So unit vector UCB. So unit vector UCB is the RCB divided by its magnitude RCB. So now we need to get what is this. So can you do that? So here, so we can resolve the force into Cartesian. So now we can have that 60 times the unit vectors. So this unit vector is B minus C. So coordinate B minus C. So you can have that. This is 1 minus 3. And then here we have plus with 3 minus 4 J, and then plus 2 minus 0 K here. And then this is the magnitude for the RCB. So here you have negative 2, 1 minus 3 is negative 2, plus with the negative 1, 3 minus 4, exponent 2, and then 2 minus 0 is 2. So you can solve here. So you will get the when you solve the 6 Newton, multiply with the unit vector, so you can have that the force in Cartesian is negative 40I minus 20J plus 40K Newton. So this is the F. So now we have obtained the R, right? So now we have obtained the RAB. So now we can solve the first part. Okay, the first method, which is the MA is equal to RAB cross F. So now you can write the determinant here. So you write the I here, IJK, and then this is the RAB, and then here is the force. So this is the force. So negative, here we have negative. Then we can solve the determinant. So this is the MA. So as usual, you can solve, and then so you can answer. Okay, don't forget this one. Minus element J, and then this one plus element K. Okay, this first you cross for the I, and then minus for the element J, and then plus for the element K. Here the answer is 224 unit Newton meter. Don't forget about the unit. So here now we can have the directions of the moment. So here you may refer to this figure. So this is the F, and now this is the R. Then this F goes to this, so it becomes this as Z. So this is the moment counterclockwise. So that's why also here we have the positive. Next, we're going to use the second method, which is MA is equal to RAC cross F here, right? So here RAC cross F. So we just write into this determinant I, and then this is R, because we already determined the R before, and then this is the F. So this F is negative, and this one is negative. So you can write the determinant, this of the determinant as usual. This is for the element I, and then don't forget minus element J here, and then plus element K here. Right, so you can solve the MA is equal to 160 minus 120K plus 100K here. So now you can get, this is the vector. So from this vector you can determine the magnitude. So the magnitude is square root and exponential the vector here. So the answer, the magnitude of the moment is 224 Newton meter. Now example 4.8. So we have three forces act on the road. Determine the resultant moment. They create about the flange at O and determine the coordinate direction angles of the moment as is. So now we need to determine the moment at this point O. So we have three forces. So this is the F1. So this is the F2 and this is the F3. So luckily the F is already in Cartesian. So it's more easy. So now we need to get what is the R, right? So you need to sum. So the moment resultant is equal to summations of R cross F here. So how many determinant you can have? So you're going to have 3 determinant, right? So this is the first, and then you need to plus, and then this is another, and then plus. So the first, we need to have the F1. So F1, we need to get what is this, right? What is this R? So here we have the ROA here. So we have ROA cross F1 here. And then plus with F2. So F2 also we can have what? This RA, right? So this RA also can cross this F2. So ROA also can cross F2. And then plus the last force here. So this force going to resolve this point O. So we need to get this position vectors. These are O, B. So here the last one, we need to get what is the ROB cross F3. Right. So now, so here the next step is to get what is the ROA and what is the ROB. So you need to get what is the coordinate O here, what is the coordinate A, and what is the coordinate B. So then you can have that, what is the ROA and what is the ROB. Can you do that? Okay, now we have the ROA here and the ROB here. So ROA here is 5J. So because this ROA is already in as is J, and then ROB here is the 4I plus 5J minus 2K here. So now you can solve this determinant. So this is as usual moment resultant. Moment resultant is equal to summations of this one. Okay, this one plus. Alright, so this is the determinant. So you can write into determinant. This is the ROA, and then this is the force. So here is negative. So this is plus, and then this one is 4 negative 2. Okay, negative 30. Okay. So you may write into this determinant. Okay, this is the this one is the ROA cross F1, and then this one is the ROA cross F2, and then this one is ROB cross F3. Right, so you can solve. So you may get the answer is 30I minus 40J plus 60K, and then don't forget the unit Newton meter. So now this is the vectors, the vector for the moment resultant. So the question asks us to get what is the magnitude and also the coordinate direction angle. So we need to solve that. So here in order to get the magnitude, as usual, we can have that the magnitude is equal to the vector I plus J and then plus the K here. So you can solve, you can have that the magnitude for the moment resultant is equal to 78.10 Newton meter. Okay. So now we need to determine the direction moment. So the direction moment is equal to the vector divided by its magnitude. So when we talk about the direction, the formula is the same. So we have here, this is the vector and this is the magnitude. So here 30 negative 40 plus 60 divided by its magnitude. So now we can have that the unit vector for moment is equal to 0.394I minus 0.5121J plus 0.2 K. So now we want to determine the coordinate direction angle alpha, beta and gamma. So here you can determine this cos alpha, cos beta and cos gamma is equal to like this. Okay, so you can have alpha is equal to 67.4 and then beta is equal to 121 and then gamma is equal to 39.8 here. Okay, alright, so you can have, okay, you may refer to this figure. So now this is the moment direction. So this is the moment resultant, the vectors, and how the angle acting. So from this moment axis, so alpha is to this axis x, beta into this axis y, and then this one into axis alpha into axis z. Okay, so now we have studied about the moment of force in 2D and moment of force in 3D. So that's all for today. Hope you can achieve the outcome of the lecture in order to solve the moment of force in 2D and 3D. So see you for the next lecture.